Kevin Keys is a registered professional forester and soil scientist with over 30 years of experience. Where did that time go by? Wow. In applied and collaborative research, forest ecology and management, soil classification and interpretation, site assessment and sampling, technical and scientific writing, training and extension activities, and project management. He's a former research forester with the Nova Scotia Department of Natural Resources, the Resources and Renewables section, and co-author of the Nova Scotia's Forest Ecosystem Classification, you know it as the FEC, and the Ecological Land Classification, the ELC guides. Kevin is also an authority on regional wetland hydric soils and an experienced wetland delineator. We're very happy to have Kevin Keys with us today. Kevin.
Thanks everyone, appreciate it. Thanks Don. The talk, or the title you see there, is some thoughts on forest soils, ecology and management, and that's really what this is going to be, because it's a big topic and 20, 25 minutes is not really enough. So I'm just going to give you a few things that I think are relevant, I think, to this sector, and especially in light of Fiona and the desire to do some salvage and cleanup, and hopefully lots of time for questions as well. So everybody knows that forests are complex, and not only complex, but they're dynamic, and we all know that. But what a lot of people don't appreciate, but I think most people here do, is that the soils themselves are also complex and dynamic ecosystems. They're a component of the overall forest, but they are in some ways self-contained, or you can put some boundaries around those as well, and think about those as unique ecosystems unto themselves. Now all the pictures you're going to see of soil profiles in this presentation are all from Nova Scotia forests. As Don mentioned, I've been doing this a long time, and then with the FEC work we did, I've done personally probably over 2,000 soil pits in my career, most of them in Nova Scotia. And I don't get tired of it, because sometimes you see something new, even after that many times and that many years. So there's a lot going on there, and I'll get into a little bit of why in a minute. But these are 3 different soils. Each are going to act differently. They have different properties that are going to react different to management. They're going to support different types of vegetation in that interaction.
Could you hold that a half an inch further from your mouth?
Sure. Thank you. Lots of peas and pops and everything else? Yeah. Okay. So here's a few more of those. Again, different soils. The one on the right, top right, shallow soil to bedrock. One on the bottom left is a hydric soil, a wetland soil, or forested wetland. And the one on the right, bottom right, is what you get when you have wind throw. A lot of times, you'll have the soil kick up, create a mound, sometimes burying the original soil layer below. The tree decays, you no longer see the tree, and you have a mound left over. All our pit and mound conditions you see in our forests are historically from thousands of years of wind throw, tree decay, and mounded. So in some cases, the soil falls right out of the tree roots in a similar order as you would see it if you were digging the soil pit. So you can see that there's almost a full soil profile on top of another buried profile. And that black area you see here, that's the old buried forest floor. Anyone who's taken FEC training from me, I always tell them, don't dig your pit on mounds. And this is why. And the reason soils are so complex and dynamic is because everything comes together at this point. You have the atmospheric influence, with different gases and air exchange and precipitation coming in. The biosphere, of course, all the vegetation and microbes. Hydrosphere, all the water influence, and then the lithosphere, the paramaterial, the minerals, the rocks, everything comes together at the interface of soils. So you can see how easily it can be very complex. And I think we all agree, or can agree, that you can't have a healthy forest without a healthy soil. It all starts from that foundation. And as I mentioned already, not all soils are the same. They differ in their inherent capacities to support plants in the faunal communities. This is something that seems intuitive, but you'd be surprised, especially 20, 30 years ago, as John said, how much soils were taken for granted as being almost the same everywhere. Stand boundaries were only based on trees. They were never based on the soil conditions. The FEC changes that. We promote the idea that soils can be just as much a reason to have a stand boundary as the vegetation on top, because they are different stands if the soils are different. This is as technical as I'm going to get, but anyone who's taken a soils course in the past will have probably seen something similar to this expression. This is from Hans Jenny from the 1940s, I believe. He expressed soil formation as a function of 5 different influences, essentially. Climate, living organisms, including humans back then. Relief, better known as topography, acting on parent material over time. So soil is a function of all of those things. And if those things vary, then the soils will be different. More currently, people are putting, and I agree with this, another letter into the function A for humans, or anthropomorphic influence. And because we can do a lot of things to soils, and that's going to influence their development going forward. Basically, then, that's why there's so much variation in soil, because there's so many things that affect it over time. And basically, when you get to see a soil, actually, I'll show you one just very quickly. When you look at a soil like this, you dig a soil profile, and what I like to say to people is that think of it like you're looking at the last chapter of a book. That's the conclusion, at least for now. It's going to change in time again, but that's the current conclusion. What is the storyline that got you to this point? Can you explain why that soil looks like it does in this location? And that's what soil people do in the field. They look at the soil, they assess it, they do some measurements sometimes, they do some assessment of texture, structure, that type of thing, and they come up with a reasonable, plausible explanation as to why that soil looks like that at this location. And all the things that are gone on in the past get you there. The climate, paramaterial, time, topography, human influence, microbial influence, vegetation influence, it all comes together into this last image. And the picture doesn't lie. This is what it is. How did you get it? So as you can get from that is that soils have a large influence on the type of vegetation that grows or is associated with that site. Now this is a clip out of the new FEC guide. Some of you may not have seen the latest version of this, but the intertopic grid is what is shown on the left here. And this is basically a 2-dimensional figure showing the relationship between different sites by moisture and nutrient regime. So we have moisture regime on the left, nutrient regime on the right, or across the top, going across. And every site, every forest site in Nova Scotia, or anywhere, it's all relative. There's editopic grids for every place that you can develop them. But every forest stand or site that we have in the province can be fit into one of these areas within this grid. And we've arbitrarily divided them up into 17 units, but as we know in nature, sometimes things are right on the line, sometimes they grade or whatever, but we have to come up with some system. The area in green are sites that are not overly influenced by soil site conditions. In other words, the vegetation that can grow there naturally is dictated by our regional climate. And these are the areas that form the classic Acadian forest species that we talk about. Every other location that's in white means that soil or site is dictating what can grow there. It's either very poor, very dry, or very wet. And it's the soils that drive a lot of that. And these are the names that we've given to each of these ecosites to kind of to give you an overall picture of what would be the natural tree species climax growing on those conditions. So we get down to what makes a healthy soil. This is my opinion. We simply want to maintain ecosystem function and productivity at the inherent capacity of that system, whatever that is. And we already know it's not the same everywhere. This tells you that not every site can grow every type of tree. Not every site is the same productivity. But each of these units has a capacity to produce within its bounds. And soil health to me is making sure, or trying to make sure, that within each of those systems, the soil is able to maintain that productivity and have that ecological capacity to do so. I have simply in quotations here because it's not usually that simple or easy to achieve. That's basically what it boils down to. So in other words, let's do no harm to the soils so they can maintain their productive capacity, but also where we know we've done some harm, let's restore them as much as we can, because without doing that, you cannot have the healthy forest that that site should support. So having said that, what are some of the issues around soils and forest management? Nutrient management is a big one, of course. It's not only how many nutrients you have, it's their balance as well. And that's going to vary depending on the parent material in a lot of cases. What is the natural ability of that soil parent material that the soil is derived from to supply nutrients? How much atmospheric deposition of nutrients are you getting? And then how much are you taking off through harvesting? And how much is being lost naturally to leaching? So it's that balance. Acid rain impacts. Those who have heard me talk before probably have heard me ad nauseum on this topic. It's still an issue here in Nova Scotia. Not only are we dealing with the legacy of it, but arguably in some locations it is still happening. I did a study in 2018, I believe it was, in Kedzie Park. 22 years after sampling the same site, we took some more samples at that site, analyzed them the same way on the same pieces of equipment, no change. So that tells you that even 20 years, 25 years of air quality control in the US and States, which has greatly reduced our acid emissions, sulfates and nitrates, or nitrous oxides, I should say. Even after all that time, those soils have not even started to recover. So we're dealing with that legacy, and it's something we have to incorporate into our management. And a big part of that is the loss of base cations, which means calcium, magnesium, potassium. Those are obviously important nutrients for vegetation. And then when you lose those base cations, what you gain or increase is aluminum, and that causes stress on the vegetation. Obviously, carbon management is a big deal these days, and organic matter content. This is big in the agricultural world, but we should also be thinking about it in forestry. Biodiversity, obviously, I think Mark talked about biodiversity this morning. There's a whole world of biodiversity below your feet, but it's very complex, as I'm going to get to in a few minutes, and also a lot we don't know there. And then finally, something a little closer to home perhaps is soil damage. The different types of things that can happen to the soil that causes damage to that soil. So I'm just going to focus on these last two for a little bit. Biodiversity in soils. It's estimated that almost 60% of all life on this planet lives partly or wholly in soils. And so we have very little knowledge of all these, myriad of species and interactions, and knowledge of how they interact, and what they call functional redundancy, and what they do and what can be done by different organisms and whatnot. So this is only an estimate, but you can see how important it is. This is a bit of a cartoonish image, but it comes from a recent paper from Cindy Prescott and her research partner about continuous root forestry. It's an interesting topic, actually. We can get into that a little bit more, but this anyway gives you an idea of the types of organisms that are in soil, and just a really kind of an overview of how they interact in different levels of different levels that's there, and how much of this stuff we really don't know as much as we should or could or need to, I should say, is a better way of putting it. So as I kind of alluded to, we have we know some things about soil biology, but we probably know less than we know. No, how should I put it? We probably don't know more than we do know, is what I should say. And it's in most cases, the more you know, the more you realize you don't know. And that's all about soil biology and biodiversity. But one thing we do know is that the functions in soil, the biological functions in soil, are influenced by soil properties. And they've evolved to that condition over thousands of years. And so there's a relationship there. And so we need to minimize damaging soil so that those relationships, those functions can be maintained. So it behooves us, if I can use that word, shows my age, I guess. How many have heard the word behooves before? Yeah. Anyway, it behooves us to really take care of what we can take care of, and that is minimizing soil damage when we're doing harvest operations. So then the question is, what is damage? We don't get to that. Let me first preface by saying not all ground disturbance is damaging. I know that. So I've given similar talks to this in the past, and as soon as I say the word ground disturbance, I often get immediate pushback. The favorite one I've heard was, you can't bake a cake without cracking a few eggs. And I agree. But you can have emissions on the ground without damaging soil. We just need to know what we're doing. Different soils, as you've seen, have different properties. So that means they also have different sensitivities to different types of damage. And we need to consider those when we're doing our operations. Otherwise, we're acting blindly and we don't know how much impact we're having. Because once damage has occurred, it is very difficult to fix, if at all. And if it is fixable by humans, it's usually not as effective as what it would take 1,000 years of natural recovery to generate. So by far, it's better to avoid the damage. So let's look at compaction as an example. Soils are not just solids, as we know. Soils are solids and pore space. And that pore space is either filled with gases or it's filled with water, and it fluctuates depending on the weather and the drainage condition of the soil and a few other factors. But it's the macropores, the larger pores, that are the ones that are responsible for air exchange. And yet, that carbon dioxide has to go somewhere, and it comes out of the soil. And oxygen and air goes back in. So you have to have air exchange in your soil for it to function. And the macropores are where that happens. So when you compact the soil, what do? It's only logic. You interfere with the gas exchange. You interfere with that, then you're interfering with biological function. You interfere with biological function, you're interfering in reducing productivity. It's just a simple relationship. But then the question is, well, what's considered damaging compaction? And that varies by soil type. So here's that image again that we took or saw earlier. And these are the FEC classifications for those soils. A 2C, a 6, and an 8. These have meaning. Soil type 2C is sandy, in this case also cobbly, dry, low fertility. Soil type 6, you can tell by the color there that's very high in clay, arising either from old tillage or old pasture. Here's what I suggest are the impact levels or thresholds for damaging compaction on these soil types based on the research I did while I was still with the department over several years, and also with a colleague from UBC. Soil type 2C. If you get over 20 centimeters of a rut or a depression from your wheel track, you've damaged the soil. Soil type 6, 5 centimeters. 5 centimeters will damage that soil. Soil type 8, 15. So in this case, soil type 2C has a fairly large cushion, you might say, for wheel track compaction and rutting. But if you scalp it, take the organic matter off the surface, you've reduced the productivity because that soil is almost pure sand and rock. So there's different types of hazards, different thresholds for different soils. This is just an example here of kind of how we assess types of measures. And it is possible to measure 5 centimeters difference. So then once you know what constitutes a damage, the next question is how much damage can you tolerate before you affect productivity? And based on our study of this subject, it's somewhere between 5 and 10% by area. So once you survey, or when you go out and survey, you determine what is damaged based on the soil type, and then you determine how much of that damage has occurred on the area. And if it's more than 5 to 10%, you've likely reduced the productivity of your site long term. So my take-home message is, you need healthy soils to have healthy forests. Not all soils are the same. You need to know what the soil types are in your woodlot in order to manage for that. And don't let anyone tell you that they can tell you that just by walking, because I can't. I'd have to still stick the auger in the ground to know what I'm looking at. And I've been doing it for 30 years. So anyone that tells you that your whole woodlot is one soil type, talk to the next person, because that's not true. You have more than one, guaranteed. And the key thing beyond that is that that knowledge then needs to get integrated into your planning. This is not saying you can't harvest, you can't manage. It just means that you have to integrate knowledge of your soils and the hazards that they have into your management planning so that you do not reduce the productivity potential of your site. Now, when we're talking about salvage and Fiona cleanup and everything, this is something that should be considered. Is it worth sometimes getting some of that wood off if you're going to end up reducing the long-term productivity of your site? How do you know if that's a possibility? You know that because of the hazard rating of the soil types in your woodlot. In the Family Forest Network, some of the plots we're doing are research trials. We're trying to find out how much it actually costs to help protect soils long-term. So we'll add extra brushing. How much does that cost? What's the new cost of doing business when you don't have winter freeze-up anymore? When you have to work on wet ground, how do you prevent that damage? One way is through brushing of your trails. Well, how much is enough? And how often do you have to do it? And how much time do you ascribe to that activity? You have to figure that out, and we're actually trying to come up with those costs. As an example. Another thing is, maybe you can't haul the wood out that day. It's too wet. Because one pass of a load of porter can damage the whole track, depending on the soil type. I think we have hopefully time for a few questions. And this is my favorite soil profile that I've done in 30 years. This is from Digby County, a glacial marine paramaterial, heavily leached into this layer down here, which is now naturally cemented. We use a rock hammer to crack through that, and then get into the different marine deposits that were there below that. Quite a lot of diversity in our forest soils. Anyway, thank you.